Hello guys, I'm back with another video today. Today we're going to solve another lead code problem. So today's problem is going to be maximum product subarray. So this is the 152nd problem. So what we have to do, the objective is, so we have to find the maximum product of in a sub, like the array which is having a subarray which has the maximum product. So that is the objective here which is given. So subarray, as you guys know, it's a continuous subsequence of the array. So here right now we have a array here, so we have to find for example in this the maximum product can be a subarray 2 and 3 is present, so 2 into 3 is 6, so 6 can be the maximum. But if you want to include if you try 2 3 and minus 2, you're going to have around like minus 12, which is less. So and then if you include 4 also, you're gonna decrease it more. So here you have to keep a note on the negative values and the positive values which are present. So based on that we have to find the subarray. So here there is a approach with n cube such that you brute force the solution. So for example here you I'll show it to you guys. So here we have one, for example we have 2 3 and then minus 2 and then 4. What we do here is that we'll have two pointers. The first pointer will be at 2 and the second pointer will be at the next element I and j. So every time you'll find the product of elements between I and j. Right now the product of elements between I and j is 6. So every time, so right now it's at 6 and you move j forward, so it will become minus 12. So you keep off, so for example here you keep the max as 6. So till now whatever is recorded, that the max value, so it will become minus 12, and then it will become 4 into 12 minus 48 it would become. So this is not so then I value moves forward. So again I value moves forward and then j value starts from the I plus 1. So minus 6 you get here, minus 6 is not max, and then again you move j forward, it will become 12. So 12 is the minus 6 into 4 minus 48, that's not the right answer. So it should be continuous, so we have to keep that in mind, that the array subarray should be continuous. And then next we move I forward and then j will be back. So again you find the answer, it's going to be minus 8. Minus 8 is not the maximum value, so here it's going to be 6. The problem here is that the time complexity is going to be big of n square. You can give this as an initial solution to your interviewer, but obviously your interviewer is going to say that please optimize it more. So then we would obviously use an algorithm so such that you get it in big O of n time complexity. So for this, to understand the approach for this, first we need to understand one more question, which is kind of like a sub problem for this. As you guys know, there's a algorithm known as the cadence algorithm. So the cadence algorithm, now we'll try using it for the maximum sum of a array. Then we can understand the same, we can put the same way in the maximum product subarray. So let's try it on let's take cadence algorithm on this array. So right now you can see minus 1, this array is present, so we have to find the maximum sum of this. So what we can do is that, wait a minute, let me adjust this. Yeah, so what we can do is that so right now as we see it, we can eyeball the solution. Right now it's like here it's 1 and then 4 is present. So negative values you should make sure you should not include subarrays which give you a negative answer. For example, let's consider this subarray 0 and 1. So minus 2 plus 1 is going to give you minus 1. You're not going to include it into your subarray because it's generating a negative value. So as a whole it has to generate a positive value and it has to be the highest. So for example we have minus 2 and 1. Okay, so I have a solution for this. So for example let's try iterating from the ith element. Wait a minute, let me zoom out. Yeah, so this is a table showing all the iterations one by one. So we are at 0th element. So current value is 0 initially. So is this value minus 2 greater than the current element? No, so we're going to keep it as 0 itself, and the max is going to be 0 anyway. Initially max sum is 0. So next iteration will be 1. So at 1 is present, so 1 plus the current element is not negative, so we can add it, no problem, we add it here. And the max element is nothing but the max comma the current value, so it's going to be 1. So next iteration we get a minus 3. So 1 minus 3 is minus 2, which is negative, so we don't include it, we keep it as a 0 itself. And max is still 1, there's no change in that. And then next third iteration we see there's a 4. So 4 is present, so 4, the value at 3 is going to be 4. So 4 plus the current element is positive, so we can include it. Now the max value gets updated because we have changed the current value. So next iteration we see iteration number 4. So we have -1. So including a -1 in our current subtracting a 1 from our current value won't make it negative, so we can include it. So 3. This won't get updated because 3 is not greater than the maximum element right now, 4. So next, for fifth iteration we get +2. So 3 plus 2 we get it as 5. We can include it because it's greater than 0, and then we get 5. So like this we come till the end of the solution, and then we get the maximum as 6. So right now the maximum sum of the subarray is going to be 6 for this question. So I suggest you all go and try the cadence algorithm. This is easy problem in lead code. So normally people will ask you the maximum sum of the subarray, but other times people may even ask you the subarray. For example, here the maximum subarray is 4. So yeah, 4. So you have to just return the index of that. So 8, or yeah, so subarray of that. So the answer is 6 here right now. So 6 means the subarrays can be let's check 4. Yeah, so 3 to 6, you see, 3 to 6, 4 plus 2 plus 1 minus 1. So this you have to return 3 the subarray 4 minus 1, 2 and 1. So that's the normal approach. So let's come back to our main topic today. So our main topic was to find the maximum product subarray. So let's try understanding the solution right now. So this array is present here. So initially we'll have a okay, so I forgot to tell you the main thing. So here you can see if the value, if there's one negative value, then your answer is turning out to be negative, and if like zeros are present, then you're destroying the whole answer itself. So 0 is going to make the whole thing 0, and further all your products are going to be 0. So we need to find a solution for that. And then if you have even number of negative numbers, then we can include them because their product is going to give you a positive number, and basically it's going to increase your answer. So, and then if 0 is present, we clear everything and we start from the beginning. So we have to keep these in mind, and now we'll understand the solution right now. So imagine this array is present. So you have to find the maximum product anyways. So initially we'll have 3 variables. So product max, so the maximum value, and we have to keep the max value and the minimum value, because minimum value, if you have any negative numbers, then it'll keep that in track, and if there's a negative value and if it finds one more negative value, obviously it's going to increase. So till then we'll keep these two, and we'll keep finding the max between the product max and the product minimum every time. So initially our iterations will go from 1 to 4, 7, because initially we have stored our 0th index values in the product max and the product min and the result. So these are the initial values, so 2, 2, 2. So and then our next we'll have a temporary variable. In the temporary variable, what we'll do is that we'll find the max of the incoming element, which is, for example, in the first iteration is going to be 3, and then our next so I'll show you the whole image. So yeah, so see, it's going to be the product max. So right now 2 is the product max, and then the incoming element, and then the minimum value and the incoming element. So I'll show it in, I'll write down the code, then you guys understand it better. So the minimum value is nothing but min. So this is the maximum values of them, and this is the minimum values of all 3. So and then afterwards we'll store that product max is equal to temp. So I'll give you the reason why we are creating a separate variable called temp instead of adding this into that. So we need the max value and the min value, so that's why we are creating a separate variable called temp, so that it keeps a track properly. So then we would have the result is the maximum of the product max and the existing result. So let's try running. In the first iteration, you see the array value which is incoming is 3. So 3, and then 2 into 2 is the product max. So 2 into 3, and then 2 into 3, we have a 6 here. So product minimum is 3. Minimum of these 3 elements is going to be a 3. I'll show it properly now. So product of these 3 is going to be a 3, and then the maximum value of all these 3 is going to be 6. So our result is going to be 6 right now, because we are comparing between the result which is default 2. So 6 is greater than 2, so we will store 6 here. And then our next value temp is going to right now we have a -2 is the incoming element. As you can see here, -2 is the incoming element. So -2, and then -2 into 3, and then -2 into 6, so -12 and -6. So on we would go on till we find the maximum result. So here you can see in the 5th index, you can see 0 is the incoming element. So 0 is going to disrupt your answer. So 0 and then 0. So 0 is incoming element, 0 into -24, 0 into 288, 0, 0. So still maximum the result is going to be 288 itself. So you approach 0 here, you're going to start afresh. So from now your new subarray is going to start. So you have to make sure you don't include zeros in the subarray, because obviously the product of whatever you multiply with 0 is going to be a 0. So let's try running the code and understanding the answer right now. So initially we have the result, which is 0, and then we have a max product, which is going to be a 0, and then we have a minimum product, which is going to be a 0. So now so here sorry, it's not a 0 actually, I forgot to say this. It's going to be the first element. So in ours it was 2, right? So it's going to be a 0. The 0th index, whatever is present, that's going to be a, yeah. So and then we will start iterating from 1 to so yeah, we will iterate from 1, and then right now what we would have is that, so we would have a temp variable which would have the maximum of the product max and the product of the incoming element. So let's create a temporary variable which would have this would have the max of the this would have max of the maximum product, the incoming element, and then you can see here maximum. So yeah, and then I into it's going to be the minimum product, and now we will find the min product. Everything is going to remain the same except it's going to be the minimum of these three. And then yeah, so and we would store our maximum, our temp value in the maximum product, and then the result is going to be the result and the max product. In the ending we would return the result. Hope everything is good till now. Let's try running it. Yeah, so let's try for this test case which we have here. We must get a 288. Let's see how it converts properly to text. We'll do one thing. It's going to be a 2, 3 minus 2, 2, 3 minus 2, 4 minus 6, 4 minus 6, a 0, a minus 2, and then we have a minus 2, and then we have a 5. Yeah, we got a 288. Let's submit our code. Obviously I already submitted the code before. Obviously if it wasn't right, I wouldn't even make a video on it. So I hope you people understood the thing, and then I suggest everybody use this formula and try making a table out of it. If you make a table and dry run it, you'll understand it better and you'll understand what's happening here. So thank you very much. Please subscribe.